friends, welcome back. The class begins again. Today we will learn what is hydrogen bonding. A hydrogen bond is a partially electrostatic force of attraction between a hydrogen atom and a more electronegative atom or group such as nitrogen, oxygen or halogens. It is an attractive force which occurs in any compound whose molecules contain OH or NH bonds like in water, alcohols, acids, amines and amides. The oxygen-hydrogen bond, for example, is a highly polar bond. Oxygen is more electronegative than hydrogen and pulls the bonding electrons closer to it. As a result of this displacement, the oxygen atom acquires a small negative charge and the hydrogen atom a small positive charge. Adjacent molecules of the compound containing oxygen-hydrogen bond will be attracted to each other by virtue of these opposite charges. This force of attraction is known as the hydrogen bond. Usually, a hydrogen bond is represented by a dotted line. Hydrogen bonds can be intermolecular, means occurring between separate molecules, or intramolecular, occurring among parts of the same molecule. Intermolecular hydrogen bonding is responsible for the high boiling point of water compared to the other group 16 hydrides that have much weaker hydrogen bonds. Intramolecular hydrogen bonding is partly responsible for the secondary and tertiary structures of proteins and nucleic acids. It also plays an important role in the structure of polymers, both synthetic and natural. Depending on the nature of the donor and acceptor atoms which constitute the bond, the geometry, environment, the energy of a hydrogen bond can vary between 1 to 40 kilocalories per mole. This makes them somewhat stronger than a van der Waals interaction but weaker than a fully covalent or ionic bond. Although the strength of a hydrogen bond is much less than that of a covalent bond, it has a very significant effect on the physical properties like boiling point and solubility. Let's study the effect on boiling point. It is understandable that substances having nearly same molecular weights have the same boiling points. The boiling points of alkanes and ethers of comparable molecular weights are not far apart. But the boiling points of alcohols having almost equal molecular weights are considerably higher. This can be explained on the basis of hydrogen bonding. Ethanol forms hydrogen bonds. Extra energy in the form of heat is required to break the hydrogen bonds holding the molecules together before it can be volatilized. Propane and dimethyl ether do not form hydrogen bonds and therefore they have low boiling points. Now the effect on water solubility. A hydrogen bonded substance is usually soluble in another hydrogen bonded substance. For example, alcohols are soluble in water, but alkanes are not. This is because a non-polar alkane molecule cannot break into the hydrogen bonded sequence in water. It cannot replace the hydrogen bonds that would have to be broken to let it in. An alcohol molecule, whereas, is capable of hydrogen bonding. It can slip into the hydrogen bonded sequence in water. It can replace the hydrogen bonds that must be broken to let it in. Therefore, a hydrogen bonded substance is soluble in another hydrogen bonded substance. So, to summarize, hydrogen bond is an attractive force between hydrogen and more electronegative atom like oxygen, nitrogen or halogen. And although it is weaker than covalent or ionic bond, it significantly affects the physical properties of the compounds which form them. That's all for now. If you like the video, please hit like button and don't forget to subscribe. It's absolutely free. And also press the bell icon so that you can get the notification as soon as I upload any new video. Okay friends, we'll meet again in the next video with some interesting concepts. Till then, keep studying, keep rocking. Bye-bye.